So hello everyone. Uh, Today we will go to thermodynamics a little, and in this video we will be solving these two problems as you can see on your screen right now. But these two are from Irodov, and this is specifically on the relation between entropy and temperature. So I mean the base of these two problems are actually based on just one formula, and that is nothing but this thing. Wait a minute. Just wait a minute. It's okay now. So that is basically just this thing. You all know, right, the definition of heat capacity. So that's basically defined by del Q by del T, or the change in temperature of an object if its temperature changes by a unit, be it Kelvin or degree centigrade or whatever. So both the problems shown in this picture, these are based on this concept. Okay. And another thing you know, right, that delta Q, I mean this is more useful in chemistry, but in physics you will require this sometimes. So delta Q is equal to TdS. And notice one thing, this is a very small thing, but still mathematically sometimes you do wrong. Why have I written delta beside Q and D beside S? Because Q is a path function, right? So I am not writing it here, but just note that I have written delta beside Q and D beside S. That's basically because Q is a path function and it's not a state function. So for changes in path function in thermodynamics, we usually write delta, and for changes in state function, we can write that as D. Okay. So anyway, let's get along with the problem. And to be honest, let's solve the second one first. So this is a very general problem, and something like this, I mean these things, maybe they're on JEE Advanced, because the relationship between temperature and entropy, that's actually very famous, to be honest. Okay. So anyway, what does it say? Find a temperature T as a function of entropy S, and literally nothing more is given in the problem. Okay. You can, I mean, from this one thing is one thing is very evident, that you can find T as a function of S in any given condition. Okay. So let's begin. So this is the definition of entropy. So ds, this is basically delta Q by T, and what we had now, let's differentiate both sides by, I mean let's divide, not differentiate anyway. Okay. So now this del Q by del T, this term is nothing but your C. But let me give you a twist. Let's write it as CT. I mean, it's not a necessity that C is constant, right? You will see problems where C is a function of temperature. So I mean that's not necessary that C would be constant. Anyway, let's solve now from here, and so we can write that ds, this is equal to C, though it's partial differential equation, but we may write this in this case, I mean because there are no other variables rather than T. So now let's solve it. So now, I mean let's integrate. So after integrating, we will get a very general formula for these types of problems. is equal to from T naught, this is from T naught to T, C of T by T into dt. Okay, so so let me write the general formula now. Let's write it in white. The formula is basically S minus S naught, I mean what you get after integrating. And in the general formula I just will not open this integration because I do not know the CT. I mean I am writing it as general. I am not really solving the problem now. I am just writing the theory, and this, let me tell you, this might be useful in any of the examination. So anyway, okay, so this is a very important formula for your thermodynamics. And now let's come to the problems. Okay, you can solve this by, I mean using this you can solve any problems like this, but now let's come to the problem. And now I have derived this formula, so let's apply it directly. Okay, in the second problem, this is S minus S naught into, and in the second problem let's I think it C is constant. If C is not constant, C is a function of temperature. We had that C is Ct, so the last formula I derived, that's basically the answer, but it appears that C is a constant here. Okay, so this will be basically T naught to T dt by T. So hence we can write that S minus S naught, that is C into log base C T by T naught. I am not writing them all, as T and T naught both are positive numbers. So, and we can, from here we can directly write that T is equal to, I mean I am writing directly S minus S naught divided by C. For the second problem, that's basically your temperature as a function of entropy. Okay, so it was actually it was an easy one, and but a nice one. I mean you may mess up this if you don't have the basic concept of temperature, entropy and these things. Okay, now let's come to the first one. This appears to be even more easy. Anyway, let's do it. So what we have here, we have that they have given temperature as a function of entropy, and this is, they have given that this is A into S to the power n, where n is some constant, A is some constant. So let's write S as a function of T in the first step. So this will be basically T by A, and what we had little ago, ds is basically our delta Q by T, and C is equal to del Q by del T. So let's just differentiate. Okay, let's just no, wait a minute, before differentiating, can we do some better things here? No, let's just differentiate this. So our ds, let me get the arrow here, ds, this will be basically 1 by n T by A to the power 1 by n minus 1. I did actually do one mistake here, very small. Oh, wait a minute, this should be A, right? This would be A. Okay, So now write ds as del q by t. So is equal to, okay, let's take the t to that side. So we get del q, and this will be nothing but 1 by n into t by a to the power n. Okay, a nice expression. And oh, I just forgot one thing here. There will be a dt here. Okay, so now we can just take the dt in that side. Oh, I have done another small mistake. This is supposed to be 1 by n. Now it seems perfect. T by a divided by 1 by n. And in the question they have asked to find corresponding heat capacity of the substance as a function of S. We have ascertained it as a function of T. So, and T by a to the power 1 by n, this term, this is nothing but S. So we have our final answer. I mean, this substitute S, and this is C, right? The left hand side. So that's the final answer. I mean, this problem is a little more important than the previous one from the view of JEE Advanced. I mean, this can be asked in single correct type or something like that. So anyway, this was the whole thing. I mean, the objective of solving these two problems was basically to give you a view of the relation between entropy and entropy and temperature. So basically, if your chemistry is very good, I mean if your thermodynamics in chemistry is very good, then you may probably have done this type of things, because actually this is more chemistry than physics. Okay, just we are writing we are writing del q is equal to del u plus del w rather than the chemistry one. Delta u is equal to q plus w. That's the first law for chemistry. I mean, we didn't require the first law for solving these two problems, but anyways, these this was for basically entropy and temperature relationship, and you can check out more problems on this. And after, just remember two things. I am writing them in the middle, that these are the key things. First thing is, always remember this relationship, and the good thing is this thing also holds in chemistry. So there is no contradiction between physics and chemistry in this part. Okay, and also remember that C specific heat of a process, this is for a process. Okay, for a process means for any process, be it isothermal, adiabatic, or any polytropic process, anything. For any process you can write these two things. And have I missed something? I don't think so. So these two are the main things you have to note. Okay, so if you know these two things, your thermodynamics, not thermodynamics, but relation, these type of problems, and there are also like they can also give that PV, some relation between P and V, and then ask you to derive the relation between T and S. So that is also a type, but that has to be solved similarly. So you can do those type of problems. The concept is the same, remains the same. So that those will require just little more manipulations and little more calculations. But yeah, concept remains the same. and this is the whole thing. So for today, I think we conclude here, and this was on thermodynamics. I will have more videos, probably on waves, on oscillations, on electrodynamics, many things. I am planning many things, but for now, yes, for today that's it. And I hope you enjoyed and hope you learned the concept. And as always, thanks for watching, and maybe we'll see you in the next video. Okay, bye.